Swadika. Good afternoon, ladies and gentlemen. Be with me again with the webinar of APC today. I'm Rose Chitanwat. I'm going to be the moderator for the session today. Some of you may have heard about APC earlier in the session of the webinar sponsored by APC earlier that focused on the swine nutrition. Today, it's very interesting that we have very well-known good speaker, which is in the world level, who is writing the books as well together with us today. For today, the APC webinar will focus on the key strategies in early chick nutrition to optimize lifetime health and performance. So together with me today, we have the management from the APC, and the nutritionist and the technical director who is from APC. So right now I would like to start to go through the program together with you guys and be ready for the first presentation. So the presenter for the first one will brief you a bit on the APC after you see a very beautiful slide earlier already. So Mr. Ramesh Subramonian, he is the Director of Sales Asia Pacific for APC, will present about APC for you guys, so around 10 minutes. Then we go through the well-known speaker. He is the renowned poultry nutritionist in the world, I would say, and he also have the books on chicken nutrition that you may see later on. Mr. Kleyn, he is the specialist nutritionist. He spent a lot of time on his career on make incremental gain in bird health and welfare. So let's listen to him later on. And our last speaker will be from Mr. Dr. Ricardo Esquerra. He also specialist in the technical for the livestock sector. So in order to go through the first presentation, I will send this stage to Mr. Ramesh Subramonian to brief about APC. Please, Ramesh.
Thank you, Ms. Rose, for the invitation. And I'd like to give a brief about what APC do. We have some interesting speakers. As Ms. Rose said, we have one speaker from South Africa and the other speaker is from Brazil. We thank you for your time, and I'd like to give an overview about what we do in APC globally, as well as what we do in Asia. APC is part of the Lauritsen Group. It's a privately held company founded in 1975. So it's about 45 years in the business. We are headquartered in Ankeny in Iowa State in US. The group has a production facility, about 60 production facilities worldwide with 2,400 employees. The focus of the company has been on value-added protein technology, its extraction and fractionation from complex biological fluids, and its scaling up. If you look at the promoters themselves, started the business over 100 years back with a dairy creamery, and now the company has evolved to become a company which supplies into the animal nutrition, into the human nutrition, and also into pharmaceuticals. The Lauritsen Group of companies have 7 companies under its umbrella, and APC is one of the largest companies in the group. APC was formed in 1981. It's about 40 years of history, and we are also based in Iowa in the US. We are currently the world's largest manufacturer of spray-dried plasma functional proteins. With a global reach in terms of sales and marketing, we cater to the livestock industry as well as for the agro-based industries. The commitment, if you look at the cornerstone of our success, has been our commitment to research and innovation. We have 2 innovation centers. One is in US and another is in Spain in Europe. And we also have collaboration with some of the leading universities around the world to do our research work. These are the products. You would have seen the products. It's known by AP920 is a plasma product, and AP301 is a hemoglobin, or we call it red cells. So we did a rebranding exercise this year. Now AP920 will be known as Amplify 920, and AP301 will be called as Fortify 301. We have the porcine as well as a bovine range of products. We also have in the powdered form as well as in the granulated form of these products. If you look at the product application, swine is our largest application, and it goes into nursery pigs after weaning for 2 weeks. The next big application that we are seeing a lot of growth is in the chick phase in the poultry side. So that is one of the reasons why we have organized this webinar to speak more about it and share some of the research findings that we had on these products. In aquaculture sector, we supply the hemoglobin, which is a highly digestible source of protein. We are one of the largest suppliers in the region. We also cater to the companion animals like dogs and cat food, both in the wet and dry pet food sectors. We also present in the ruminant sector, especially in the North American side, where we use as calf milk replacers. We also have business as a biostimulant, supplying organic source of free amino acids going into horticulture and field crops. Some of the facts are like in the year 2008, the American Society of Animal Science did a survey among the top nutritionists in the world to identify what are the top 10 discoveries in the past 100 years in the swine nutrition. And in that, plasma ranked number 6. APC is the founding member of the North American Spray-Dried Blood and Plasma Producers Association and also in the working group of the American Feed Industry Association. APC has been granted over 20 patents in US and in Europe related to the collection, processing, and feeding of blood and plasma protein. All these have resulted in more than 500 peer-reviewed papers and publications related to the mode of action on biosafety and efficacy of plasma proteins across different species. This is a common question that we get. How is plasma made? So we follow the WHO guidelines in terms of the plasma processing, which is similar to the human transfusible plasma. We have several virus inactivation steps, which is quite robust to ensure that the product is safe. All the plants that we have, we export the products are audited by individual countries to ensure that the process are followed and is approved. And then only these products are exported into the individual countries. We also use the blockchain technology to ensure traceability and also which is species pure. You exactly know from which plant it is coming from, which country it is coming from, and from which species it is coming from. So just to have peace of mind that this product is absolutely safe for use. We have a global presence in terms of a manufacturing and sales operation. If you look at North America, we have 7 factories which is spread in both in US as well as in Canada. Most of the supplies which comes into the Asian market is coming from the North American market for us. We also have production facilities in Europe, spanning from Northern Ireland, in England, in Spain, in Poland. We also bring some of the products into the Asian market from the Spanish plant as well as from the Northern Ireland plant. We also have production facilities in Argentina and in Brazil, which also caters to the Asian market. In Asia Pacific, we have a sales office in Japan, but in most of the other countries, we operate through long-standing distributors who have been with us for a long time. This year, we completed our 25 years of association in the Asian market, and we would like to thank each of our customers and distributors who have been with us during this journey. If you want more details as to whom to contact in each of the countries, we'll be happy to share the information. And if you want any further product information or where the product can be available, please feel free to contact us and we will share the details. Thank you for your attention.
All right, so I think we're gonna have more information. If you may put in the chat box if you want to know more about the information on APC or even on the Q&A box below. For those who you want to share with your friend or colleague to watch this Zoom, we also broadcast in the YouTube. So you may see on the Facebook of VIETSTOCK, Livestock Philippines and Livestock Malaysia. So that's what we want to share with you here. Very clear already that Mr. Ramesh already informed about the APC, and for those in Asia, and I saw a lot of audience from India, you may contact Mr. Ramesh to understand about the network of the APC in your country. So right now it's time to hear our expert on the early chick nutrition and its impact on lifetime performance from Mr. Rick Kleyn. He is the owner of nutrition consultancy companies, and he is the author of Chicken Nutrition, Mr. Rick Kleyn. From what I heard from Mr. Ramesh, he is working from Africa, but actually what I study about him, he is well known even in Asia. There are a lot of master class happening, and there are a lot of fan club of Mr. Rick also on this webinar. So I will not waste the time to talk about him a lot because too many people knows him already. But I learned from one of his interviews is very interesting that Mr. Rick said he likes to work, he likes chickens, and he likes to work in intensity and the size behind the feeding. So this is what he tell in one of the interviews, saying that the chicken is very competitive, fast-paced, forward-thinking, and exciting. So right now we have him with us in this webinar. So let's learn from him on early chick nutrition, how its impact on the lifetime of the chick. So welcome, Mr. Rick. Are you ready?
I am.
All right.
Can you see my slides?
Yes.
Can you see my cursor?
Yes.
All right, we're good to go. Good day to everybody, wherever you may be in the world. Doing webinars is a bit strange. I guess it's a bit like doing a radio broadcast because you never know who's listening. But I did see a few very familiar names on the list of participants. So welcome and hello to all my friends. What we want to do today, and I've tried to keep it brief, hopefully run just a little more than half an hour, is the importance of getting early chick nutrition right, because it has a dramatic impact on the lifetime performance of broilers. So all of these talks are to give us context rather than factual detail. So just bear that in mind. It's trying to sketch a scenario rather than solve a problem. I think we need to bear in mind that as our birds grow faster and faster, that first week of production becomes a larger and larger proportion of the production cycle. So we're becoming increasingly aware of how important managing this bird in the first week of life is. And we also know that it impacts on lifetime performance. So if we do well in the first week, we tend to do well throughout the production cycle. Now, all of us know that feeding this chick is a challenge. It's not a small broiler. It's a unique individual and a unique animal that we need to feed and focus upon. And the areas that are challenging for us is that the bird is physiologically yet to develop fully, and for that it requires specific nutrient treatments. Obviously, how well or poorly the bird is managed on the farm is crucial to its performance, and it's an area that nutritionists tend not to have a big role in, but in fact it plays a big role on our outcomes. And then obviously everything we do in commercial agriculture has to do with economy, and it's really important that we do 7-day weights correctly, or get good 7-day weights, good performance in the first week, because it has an impact on the economy. Sorry, I'm just trying to move my mouse. It's escaped, run across my desk. Okay, so here's the challenge that we face. And as I said, this is not a small broiler. This is a unique type of animal. And it's unique in that it has an immature thermoregulatory system. And we know this, this is why we brood birds during the first week of life. We know that its anatomy and the physiology of its gut are not fully developed. Mostly the bird has an undeveloped or immature gut microbiota, and we're becoming increasingly aware of just how important the microbiota is. The bird has an undeveloped skeletal system, and its musculature has yet to develop properly. Added to that, the immune system is poorly developed, and we can do something about that as well. And you'll see a really great example of that today. And then a thing that one tends to forget about is that the bird doesn't see very well until it's about 3 days of age, which adds a degree of, or a layer of complication to feeding this bird during the first week of life. The net result of this immaturity is that the bird utilizes both protein and energy less efficiently than an adult bird. And this is work by Amy Battelle and Carl Parsons. It's probably one of the most widely quoted bits of scientific research out there. But we know this for a fact. The bird has a reduced ability to utilize its feed. So let's start by looking at some of the key issues that we need to focus on during the first week of life. And a lot of these have got nothing to do with nutrition, but everything to do with nutrition. And the first thing that we expect is to have a clean environment. And by that, I mean, we must make sure that the load of microbiome or contaminants, pathogens is as low as possible. So we need really good biosecurity. We want clean feed. We want clean water. It's absolutely crucial that the bird be able to consume both enough feed and water, and we're going to talk about that in a moment. And it's crucial that thermoregulation and ventilation be correct. Now, I'm not going to talk about this in a lot of detail today simply because of time, but all of those of us in the industry know that if we chill chicks, they huddle and don't consume enough food. So if you brood birds poorly, you will not achieve 7-day weights, no matter how good the feed is. And like everything in our business, all of these factors are interrelated, making it fairly complicated. And I'm going to try and bring some order to this madness as we move forward. One of the things we tend to forget is that nutrition of the chick actually begins with the mother. And the bottom line is, if you do not feed them enough protein and energy, they're not going to lay an egg at all. So that's not part of this discussion, but it should be. But the nutrition of the chick per se begins roughly 9 days before the egg is laid, because it's during this period that the amino acids, particularly the essential fatty acids, the fat-soluble vitamins, A, D, and E, and things like choline and folic acid, and even some of the minerals, and particularly selenium and zinc, are all deposited in the yolk in the oviduct. And these are all then carried over to the chick. So it's essential that we consider breeder nutrition when we look at ultimate performance of the young chick. Interestingly, there's not a lot of carryover between the mother and the chick in terms of protein and energy. And any research that I have been able to find with regards to this shows that actually not a lot changes. If you change the protein level, chick quality seems to be much the same. Same with energy. When the chick hatches at hatch day, we have a major change, and that is that the nutrient supply of the bird changes from the yolk to what would be typically a corn soybean meal diet, which is what we feed in our industry. The yolk comprises fat and lipoproteins, whereas a corn soy diet comprises typically carbohydrates and protein in the form of peptides. And so this is a complete and utter shock to the nutrient or to the physiology of the bird. So as it hatches, it's given the biggest shock of its life. As we're going to discuss in the moment, the time it takes to start feeding and consuming this new feed is really, really important. Remember that there's a residual amount of yolk at hatch. And there's a lot of debate about whether it's really important if in early chick nutrition, particularly if the chick is feeding. But what I want to say to you is it's an important component of the immune system. So if for some reason you deprive the bird of feed, it's going to utilize that yolk and those lipoproteins and protein as nutrients rather than as immunochemicals. So it actually has a negative impact on immunity if the bird doesn't get to feed fast enough. We've known for a long time, and this is work published by the late David Kleyn from Israel. And what he showed very simply is that if he held birds back in the hatchery, in other words, they didn't get immediate access to feed, and he measured the intestinal weight, can you see that it is lower than when he put the birds onto feed immediately? And we've known this for a long time. The sooner the bird starts consuming feed, the sooner its digestive tract starts to develop. And in fact, this is some really nice photographs taken by Viola in Brazil. And you can see here, this is a electron micrograph of the villi in the gut. And this is birds that received feed, and these are birds that did not receive feed. So there's actual physical damage that occurs to the villi if the birds do not consume feed. So one of the other issues about the young bird is that the enzyme system is not fully developed. So the secretion of vital enzymes at hatch is very, very low. And we know that the secretion of these enzymes is triggered by feed intake. And pancreatic amylase, which is amylase, remember, is the enzyme that has to do with starch digestion, increases threefold in a very, very short space of time. I'm going to show you some data on that in a moment. But the other thing that we need to bear in mind is that bile secretion is retarded. Not only that, bile is something that is recycled. So it's reduced and deconjugated in the lower gastrointestinal tract, reabsorbed and recirculated. And that doesn't happen. So we have a bird that has a poorer ability to deal with the fats in the diet, because remember, bile is an emulsifier. And this is work again by David Kleyn and Yael Noy. And what they've shown here is the amylase secretion as the bird ages. In this particular case, it was turkeys, but they, in their paper, say that broilers were found to be exactly the same. And you can see how there's a dramatic increase in amylase secretion and all other enzymes for that matter after hatch. Just a few brief words about musculature, because it's really important in the overall development of the bird. And it's important that we appreciate that the chick hatches with a set number of myofibrils. And we believe that this cannot be changed. The way we feed this bird post-hatch has a direct impact on the muscle development, because if you feed them adequate amounts of protein, you get hypertrophy of existing muscle fibers. In other words, the muscle fibers that are there become bigger and more robust. And how this happens is that there's satellite cells, and these differentiate and fuse and donate nuclei to the muscle. So you'll remember from school biology that muscle fiber is a multinucleate cell. And these satellite cells are most active in the first week of life. However, they're also extremely susceptible to feed and or nutrient restriction. So if you can stimulate a protein intake in the first week of life, you actually stimulate muscle development throughout the bird's life. And this is really important for breast meat development. So a few words about the farm. And remember that commercially what happens is that we hatch the chicks in a hatchery, and there's a thing called the hatch window. Not all chicks hatch at 21 days of age. And in fact, many chicks start hatching 48 hours before the bulk of the birds hatch. Now, remember, these are the fast-growing individuals, so they're your best birds. And what happens is they hatch into a hatcher tray, and they sit with no food and no water for a period of up to 48 days. Now, we exacerbate this situation. Many hatcheries hold chicks overnight, so they hatch on day 21 and they're only delivered on day 22. And during this period, they lose weight, the yolk is reabsorbed, they become dehydrated, and the birds lose this ability to have rapid gut digestion, gastrointestinal development, and muscle growth. So just to share an idea with you, this is something that the Dutch are doing at the moment, and there are a number of different companies involved in a number of different systems. But in essence, what they're doing is they are hatching chicks on the farm. So they vaccinate the birds in the hatchery at 18 days of age, and then they deliver the setter trays to the farm. This particular system, they run them on some rails, and when the birds hatch, they drop off the setter tray straight onto the litter, the feed, and the water. Not only do they get an improved hatchability, but as you'll see from this paper that was published in the Netherlands, where they hatch birds directly onto feed, the 7-day weights was 190 grams. Where they delayed it, it was 173 grams. This particular paper was evaluating the use of a high-density pre-starter diet, and you can see that this too gave them a 20-gram increase. And when they fed the fancy pre-starter diet directly onto birds in the house, they got 7-day weights of 200 grams. So the way you get birds onto feed as soon as possible and the quality of that feed have a dramatic impact on your 7-day weight and your ultimate performance. So what's crucial on the farm is that we must have early access to the feed, and the only way you can do this is to make sure that the bird is physically in a position to be able to achieve feed and water intake. And as I've already mentioned to you, if you don't brood the birds properly, you inhibit this. So brooding management, ventilation is key, and then the way in which the equipment is placed in the house is absolutely essential. A silly little example. If you put the light away from where the feed is, the birds congregate where the light is and not where the feed is. So you want your light and your feeder to be in the same place. From a feed company point of view, it's absolutely crucial that we maintain the correct feed form and texture. Not only do we want the correct particle sizes, but we also want the correct grist of the grind of those particles, and that's a whole topic on its own. But don't make your feed too fine. Then we want to feed either mini pellets or crumbles. Mini pellets are a fantastic idea. The trouble is they're really expensive to make. Your pelleting capacity is hugely reduced. And if you don't make them short enough, the bird perceives them as being a big food item, and it can impact on intake. So most people tend to feed crumbles, but you want a nice crumble size. You want about a 2 millimeter crumble leaving the feed mill without too many fines. This is some old work published by Ross, and just to show you that the 7-day feed intake and the 7-day weight are directly correlated. So if you don't get feed intake, you're never going to get 7-day weight. Some more work from Viola in Brazil, pretty similar graph, but in fact in this particular one, it's water consumption and weight gain. And can you see there's a direct correlation between water consumption and weight gain? So for any reason, birds are prevented from drinking enough water, they're simply not going to perform. Let's move on and talk about the nutrient requirement briefly. And there's a bit of a problem in that not a lot of work has been published on the nutrient requirements in the first week. And there are two reasons for this. The first is many trials, people feed a standard starter diet for the first week and to let the birds settle, and then start their proper experiment, so you don't know that. And the other thing that people do is they don't measure at 7 days of age. They only measure at 2 weeks or 21 days or whatever it is. So you lose that vital data, even although the experiment has been conducted. What I can tell you is that when you look at the response of the young chick to protein, for example, the response is almost linear. It seems to be the more protein they can consume, the better they will grow. And obviously there's an economic point. But what we do know, and I'm going to show you some examples in a moment, that whatever protein this bird consumes in the first week impacts on its lifetime performance. Not only does it differentiate the myofibrils and the muscle tissue, but it also has a role to play in the development of the gastrointestinal tract. What this does is it confuses the issue. So if you want to just make a decision about what protein level to use on an economic basis of what they weigh at 7 days, you're actually missing a trick, because whatever happens at 7 days is multiplied throughout the life of the bird. This is some earlier work published by Waiton, just showing you how even 20 years ago, we knew that as we increased the lysine content of the diet, so too we had an improvement in body weight and an improvement in feed conversion ratio. And this has not changed. This is pretty much as we understand it today. Some interesting work published using cob birds, work was done in Russia. And what they did is they fed different levels of digestible lysine, and I put a little star there. This was the cob recommendation when this experiment was done. And what I want to show you is how the length of the small intestine increases as you increase the digestible lysine or balanced protein content of the diet. So you can stimulate the size of the gut by feeding higher protein diets. Interestingly enough, when they measured the birds at 10 days of age, at the end of the starter phase, you can see that the birds on the high protein diet weighed nearly 40 grams more than the birds on the breed company standard. But the really interesting thing is, look how this better result at 10 days of age translates to a much better result at the end of the production period. So this is an interesting concept, that the more protein you feed the bird, the better the gut develops. There is some more data and more recent data showing this. It just they were less practical diets, so I didn't use those. So the more protein, the better. So what then do we do about energy? And what I want to say to you is that the energy level and oil content of the diet is less of an issue during the first week of the bird's life. I want to remind you that the bird has a lower requirement for energy when it's being brooded because you're providing it with an external heat source. So the real limitation appears to be feed intake rather than energy level of the diet. Now, this is some work conducted by Sergio Vieira in Brazil. And you can see here are 3 energy levels, 2,900 calories, 3,000, 3,100 calories. And the blue bar is the energy intake. And you can see, yes, energy intake has increased slightly as we've increased the energy level of the diet. But this black line here is the body weight. And what I would refer you to is the axes. And can you see that we're talking about grams of difference in gain? This is 130 to 140 grams. So it's almost marginal and almost nothing at all. So very little response to energy in the first week of life. And this is an interesting bit of data showing 3 different energy levels, 12, 12.5, and 13 megajoules. And what they did is they measured the feed intake in the first week. And can you see in the first week of life, the feed intake, the energy level of the diet made absolutely no difference to the feed intake. Although obviously, if you fed a high energy level diet, you had a high energy intake. By week 2, you can see that the very low energy diet, the birds were consuming slightly more feed. But by week 3, you see the typical pattern that we would expect to see: lower feed intake at higher energy levels. What's interesting, in the 3rd week, you can see that the energy intake is the same. So the bird actually consumed enough to equalize its energy requirement by week 3. But in week 1, they didn't have that opportunity. So how then do we provide this bird with protein and energy? And obviously we have to use different feeding strategies. And I want to say up front that I think that using the correct ingredients is probably more important than getting the specification correct in these baby birds. Remember, we want a highly digestible diet. We don't need a palatable diet as you do when you're feeding swine. And what our overall objective is to maintain the gastrointestinal environment. So we want constant level of substrate. So we want the same amount of starch not being replaced with other sugars, for example. We want a consistent pH. We want to try and maintain a consistent dietary cation-anion balance. So in essence, what we should be trying to do is use mostly the same ingredients in all phases. And it's really important that we avoid variability, and we may need to eliminate certain ingredients or suppliers out of our purchasing decisions for this reason only. So in the first week of life, feed quality should be excellent. And the first thing we want to do is we want to make sure that we have ingredients of a high biological quality. In other words, they should taste good. They shouldn't smell funny. They shouldn't be wet. All of the normal checks that you do when you receive feed into a feed mill. Obviously, these ingredients need to be highly digestible. So that means avoiding ingredients that are high in ash or high in fiber, for example. If you're using materials that have been processed, it's essential that they be correctly processed. And we know that if we overcook soybean meal, the protein is less available to the chick. If we undercook soybean meal, we have basically the same problem because the trypsin inhibitor has not been destroyed. Obviously, we want our grains to be free of broken kernels. We don't want to see any moldiness. And with a bit of luck, we've got no mycotoxins in there. And then obviously, we want the correct texture. We don't want particles that are too fine. Neither do we want particles that are too coarse. Whenever I show this slide, I end off by saying this: that however good you think you are at making sure your feed is excellent, you have to try harder, because this is the cornerstone of successful chick nutrition. So some general guidelines that I can able to give you about ingredients is that you want most of your energy in the chick to come from carbohydrate and not fat. Remember, the bird has a reduced ability to deal with fat. Your protein sources should have a high biological value and should be highly digestible. As I've already mentioned, you don't want fiber or ash, and it's essential that we try to remove all of the pro-inflammatory agents in the feed. These are the anti-nutritional factors such as phytate, such as trypsin inhibitor, and such as beta-mannans. And then, as I've already mentioned, we require optimal processing. So let's have a look at a few of the standard ingredients. I'm just going to start with grain. And I want to tell you that maize is the superior grain for chicks because it's more digestible and it contains less non-starch polysaccharide. The starch in maize is highly digestible, about more than 90% digestible, so this isn't a major issue. The other good thing about maize is that it has adequate levels of those essential fatty acids that the young bird requires, whereas wheat does not. And as I've said before, whatever we do, we must not grind maize too fine. Fine maize tends to be a problem in the gizzard of the chick. This is some work done by Ravi Ravindran, and just to show you the gain in 3 to 5 days, so right in the middle of the first week, and you can see that they got the best gain on maize, followed by sorghum, and the worst was on barley, and then wheat. So really, we want to use maize-based diets if at all possible in the first week. We have to talk about soybeans because they are our major protein source in our industry. And we know that they are reasonably digestible, somewhere between 83 and 87%, so let's call it 85, which is not nearly as digestible as maize. However, any undigested material here becomes an energy source or a substrate that the microbiota can use as a source of fermentable material. Remember that soybeans also contain antigenic proteins. These are the glycinins and the beta-conglycinins, and these have they stimulate the immune system in the bird. So you can, if you have high soybean levels in your diet, you can increase, you can actually create an enteritis, which is actually an immune response. Remember that the hull is generally indigestible, so if you can remove the hull, you're going to have a better quality product for small chicks. Conversely, full-fat soybean meal, generally speaking, the hull is not removed, so you have a high hull content, but you do tend to have a higher energy content. I always worry a little bit that we ascribe too much energy to these full-fat soys for baby chicks, remembering that they can't use the fat that efficiently. And they require excellent processing. We've always used to say, oh, soybeans between 0.1 and 0.3 on ureas was fine for broilers. Well, I want to tell you, you need to revise that figure in broiler starter diets, and you probably want to be somewhere between 0.05 and 0.1. And as a rule of thumb, I try not to exceed 30% of the diet as soybean meal. Having said that, I'm not sure how important it is, because when you go and look in poultry science, you see how many experimental diets have got nearly 40% soybean meal in them. So perhaps I'm wrong. Some work out of Brazil just showing 44, 46, and 48% soybean meal. And you can see that as you reduce the amount of fiber, so you've got more protein, you get better feed intake and better weight gain in the first week. So good quality soybean meal is absolutely essential. There's some other standard ingredients that we need to probably talk about. In my part of the world, we use a lot of sunflower, and it's a really good source of digestible protein, in addition to which it contains no known anti-nutritional factors. It has a high fiber content, and some of this fiber is excellent for stimulating gizzard development, but if you have too much, you then retard feed intake. So it's about balance. Rapeseed products are not as exciting. They are lower in protein than sunflower, but also high in fiber, and it's not the nice coarse fiber that sunflower's got. Then there's some products like prime gluten. It's a great product for chick diets. It's highly digestible. Remember, though, that it is deficient in lysine, which isn't a real problem because these days we can feed synthetic lysine or to replace that. The other standard ingredients that have been widely used in the past, for example, is fish meal. It has a particularly high biological value, but you run the risk of it being over-processed. And if the protein content is low, that is often because it's high in ash. So it's a great product, but it's quite variable. One of the problems with fish meal is it's becoming really expensive and it's less and less of an option. And in my country, there's hardly any fish meal used in the poultry industry at all anymore. It's just priced itself out of the market. And we've learned to use other ingredients to replace it. Other animal products are good because they help you reduce the amount of soybean meal. However, they can vary hugely in their level of digestibility, and many of them can be high in fat and or ash, and that fat can often be oxidized, so rancid. The other problem with many animal products is they do represent a biosecurity risk, particularly salmonella. So let's have a look at a few novel feed ingredients that are increasingly being used. The first is fermented soybeans. The second is the topic of today's seminar, which is spray-dried blood plasma. And then there's some things like insect meal, and that's all I'm going to say about insect meal for now. We simply do not have enough to even test it properly at this stage. But these fermented soybeans are an interesting source. Remember what the soybeans contain these antigenic proteins, and they also contain some indigestible pentose sugars, mostly stachyose, and nothing that we do in the heat process does anything to these. So what they do is they use a solid state microbial fermentation. There's in some of the systems they also use fungi, and what this does is it alters the native composition of the soybean. So the stachyose is fermented into lactate, so you get an increase in lactate. The glycinin, these large protein molecules, is reduced by half, and you get an increase in the metabolizable energy of about 10%. This is an attractive ingredient for baby chick diets, I want to tell you. And then another novel one is spray-dried blood plasma, and we're going to hear more about that today. But I want to start by just telling you it's a highly digestible product and it's extremely consistent, which is not the case with all animal proteins. As you've already seen, it's produced under strictly controlled conditions, and it's rich in functional proteins. These are proteins that have a direct function in that form within the bird. And these functional proteins support specific biological functions, growth, tissue repair, and particularly immunity, as we're going to see. The bottom line is this product has lifetime benefits in the broiler. So I'm going to end off here by giving you a few take-home messages. And the first thing is, if you don't achieve feed intake on the farm, all the stuff I've talked about is irrelevant. So get feed intakes right. The second thing is protein quantity and quality is probably the single most important aspect of our diet for baby chicks. Energy is probably less crucial. It doesn't seem to make a big difference to the bird, and there's not a lot of sense in feeding a lot of fat to these baby birds. And then, as I say, simply avoid ingredients that are high in fiber and high in ash. Remember, the chick is not a small adult. It's its own unique being, and a good start is absolutely essential. So whatever you do, make sure you get this right. Whatever happens in the start impacts on lifetime performance and profitability. Now, there's a lot we still don't understand or don't know, and we need to investigate. But we already know a huge amount. So if you implement a few of the simple ideas that I've talked about, you will see that you can improve your 7-day weights, and through this improve your returns. And I want to end off by doing some advertising, by informing everybody that my next book that I wrote with my old university friend Peter Crystal has been finished. It is at the printers, and it should be available early next month. And with that, thank you very much. I'm going to stop sharing the screen and go back to Ms. Rose.
All right, thank you very much. That is very comprehensive presentation that you put together in the 30 minutes time, which is definitely not enough time for all the audience here to learn. Anyway, we can read on the book of Mr. Rick that will be published soon. It's at the printer, so you can follow his book. For now, we have a lot of questions already in the Q&A box. So if you have questions related to what presentation Mr. Rick has been presented, and you want to have more questions, please drop your question on the Q&A box in the Zoom function. And if you are interested in the presentation, the slide share, Mr. Ramesh will be in contact with the individual requests that have been put in the Q&A or the chat box. So now we learn a lot about the early nutrition, how is the importance of the fast feeding at the very first age, first day, first hour of the chick, and learn about the new technology that adopt in Europe now, even on the hatching on the farm. So the importance of the early nutrition is show that its effect on the performance of the broiler. Right now, we know that APC has developed the spray dry plasma products for the early nutrition, how it is effective and how to utilize in the early nutrition. We have our speaker who is the Global Poultry Manager from APC with us today, Dr. Ricardo Esquerra. Luckily, he was my office mate in the past also with the personal known about him. He's very knowledgeable. His work on the technical service, he works on the sales part and also on the nutrition and even service in the big country like Brazil that has a lot of poultry production in the country. With knowledge of Dr. Ricardo, he has extensive experience in developing technologies and applications related to the poultry productivity and nutrition and animal health. If you have seen some of the interview with the IPVE show, Dr. Ricardo has expanded the global technical team of APC during this year. So congratulations to Dr. Ricardo and APC that have such a great knowledgeable person in the team. So right now, don't to waste time, we are going to let Dr. Ricardo open his video and cover on the spray dry plasma is a key ingredient in early bird diets for broiler. This is for the continue us from Mr. Rick talking about how important of the early nutrition in broilers. So please, Ricardo, I give the stage to you.
Many thanks, Mrs. Rose, for the generous introduction. I was having some problems with the video.
I thinking you don't need to use the virtual background. Let's use that.
Yes, I'm having those issues still. So, but anyway, let me share my screen.
Yep.
Can you see my screen now?
I saw your screen. Yeah.
Oh, okay. Okay. Well, so thanks for the generous introduction. Today I'll be talking about spray-dried plasma as one of the key ingredients in early diets for broilers. As Dr. Rick Kleyn in his excellent presentation mentioned, is one of the novel ingredients that is being used in early nutrition diets. So there is a lot of development also on the production side and on the safety side of spray-dried plasma. Basically, spray-dried plasma is the liquid portion. When we centrifuge the blood, it is the liquid portion of the blood of animals. It actually, the processing is very interesting if you have the chance to dig into it. It follows the World Health Organization guidelines for blood plasma for human use. So there's many redundant steps on the production of plasma to make sure that it is a safe product. So it is actually recommended in breeders, in broiler breeders, and so on, because of these biosafety steps. It uses temperature shock step, for example, of at least 200 degrees and 80 degrees throughout substance. That's one of the things. In the US, for example, its process is audited by the USDA, which is more for human use rather than animal use, and not by FDA. So it is not really considered a rendering product. It is also considered a category 3 ingredient in Europe. That means that it is an ingredient that is suitable for human use, but is for commercial reasons used in animal applications. For example, in that category, we have also lactose, which is used for chocolates, but it's also used in piglets. So, and therefore is not a rendering product. So, and in the European legislation, also as in the North American legislation and in Brazil, it is actually allowed to use spray-dried plasma in poultry and in pigs. So spray-dried plasma is also used in a number of human applications. So that talks about the safety of the product. And of course, the batches are delivered salmonella free. So another characteristic which is interesting is that the water activity is low, is less than 0.6. So, and as you know, you need a higher water activity to promote growth of bacteria. So we actually have tested salmonella, for example. We put salmonella in the product, and then we take samples of salmonella over time, and salmonella dies out. It cannot reproduce, or bacteria do not reproduce with such low water activities. So anyways, there's a lot of information on biosafety, and the process is very interesting, and a lot of innovation in that area too. So the main use of spray-dried plasma is actually because of its role in immune modulation. Of course, it's a very highly digestible source of protein in the diet, and that, if not in itself, actually produces some benefits in young animals. But it is because of its effects in immune modulation that we will be using it. That's the main reason. Dr. Mike Coggott, we had a discussion with him. You know, he's a very well-known immunologist in poultry and a speaker in different places. He's also the editor of this journal, Microorganisms. And we were talking to him, and he said, you know, it would be very nice because we have a lot of information in our database. It would be very nice if you do a review paper on the effect of plasma. So, and this is a summary of that paper, and it is a cause and effect graph. And you see that there's a lot of information on how plasma changes cytokine modulation, how it increases defensins, how it actually lowers inflammation activation, inflammatory activation and infiltration. There's a lot of information on structural integrity. And of course, early development of immunity is an effect that is important, and it should be one of the key objectives of early nutrition in animals. So, and that produces, you know, an efficient immune response and so on and so forth here in green. But in the end, what you will see is a better feed efficiency at the end of the production cycle of the chicken, better weight gain and lower mortality. And something that is characteristic also of plasma is to increase resistance to disease and stress factors. So, and that is what actually will be justifying the use of plasma in the first diet. So we did a meta-analysis very, very recently. There is this is a project led by Dr. Everton Krabi from Embrapa in Brazil, and we also have a statistician in the group and myself. And this is a comprehensive study, and it will really show, or it really shows what is the effect of plasma in chickens. The meta-analysis was comprehensive, so it is everything that is published out there in the literature that we know that it exists. There's a couple of occasions that we know that the authors did the work, the research, and they are planning to publish it very soon. So we actually went ahead and included those two pieces of research. One of them is from Bob Swick, who has been working extensively with spray-dried plasma and has a number of publications on that. And the other one is a work from Mexico. So in total, we have 29 experiments, and as I said, is everything that we know that it exists, that is published or will be published soon. And then 92 treatment comparisons. So we compare the plasma versus its control group effect. And then overall, these experiments had about 9.6 replicates per treatment. So, and this is the list actually of the studies included. I put them in alphabetical order. As I mentioned, there is this one that will be submitted for IPPE, and then it will be published. And we know it was following rigorous scientific guidelines to do it. And also, of course, Bob Swick, number 28, that we know that the data exists and that will be published. So anyways, you see the countries, Mexico, Brazil, Australia. There's quite a lot of work in Australia, in Brazil, in the US. There's a work in Thailand, there's work in Europe, Japan. And then you see where this work was actually published or presented. So, and then you see the number of replicates, and then you see the treatments. And what we did, we actually, one of the criteria was whether it had a challenge or not. So a challenging situation was either heat stress or it was a pathogen being introduced in the experiment or being reported in the experiment. And that is a challenge in this criteria. And then we actually reported what was the benefit of plasma under a challenging situation and under a non-challenging situation. And then time of exposure to plasma, you see there's trials that fed plasma up until the end, and there's trials that fed plasma just for a few days. So anyway, so these are the results of the meta-analysis. And this is, you can see this is body weight gain change over the control group. You see the intercept of this regression. You see this is the 0. So in 5 and 10s of 5 will be a 5% improvement in body weight gain compared to the control by the time the birds were slaughtered or processed, or they were at processing age. In some cases, the trials finish at 21 days of age, for example. That is not an age, that is processing age. So we separated that analysis, and we also identify the effect in the starter diet. So I'm showing just the overall performance here at the end of the experiment. So you see that we also did a bias test. So this is a groups test. It's a very interesting one because it studies the distribution of the data. And you can actually detect statistically if the data was actually selected to prove your point or in a biased way, or if you eliminated some observations and skew the data in your favor or in favor of a hypothesis. In this case, the bias test is not significant, so that means the data has a normal distribution. So, and it's an important measurement for the quality of the data. So, one of the things you see is that the response to higher levels of plasma is not an ascending linear response. So this means you need a very little amount of plasma, actually. This is plasma intake, okay, in the x-axis. So that means you need a very little amount of plasma to see the effect of plasma in these animals. So with an intake of 3 to 4 grams, which will be in this area, that is enough to have a significant effect on plasma. And that is good news, because that means that is an economically feasible technology. So and today we recommend plasma only in the first diet. And we know based on this data and based on the other reports that most of the value of plasma is captured in the very first days of life. So this is the difference in body weight gain. So that means you will improve about 2.13% the body weight gain at the end of the life cycle of the chicken. This is intake. There is not a lot of effect on feed intake. As you can see from this graph, this is not statistically significant. We found in this analysis, I'm not showing that data here, that it actually increases feed intake in early chickens if there is a challenge. So young birds on their challenge, they do increase intake, but other type of populations do not. So the feed intake is not the main benefit of plasma. It is actually feed conversion. So here you have feed conversion, and then you see you improve about 2.32% on average. And then we use these equations, and then we use this information on whether the experiment had a challenge or not, to calculate what is the benefit of plasma with 3 grams of plasma intake, which is the recommendation today. I will show that later. So a very significant effect on feed conversion. Not many people report mortality in studies, interestingly so. But still, you see an improvement in livability when you actually use plasma. So you see much less data there. But there's an improvement in livability also. So the main effect will be feed conversion, then body weight gain, and then livability. That will be the main effect of plasma. So what happens if you feed 3 to 4 grams of plasma, which is the recommendation today? This is 3 or 4 grams of plasma cumulative intake. Is not per day, okay? So I'll explain that later with more detail. So this is body weight gain improvement. This is improvement in feed intake. This is feed conversion ratio, and this is livability. So, and these are 4 different trial conditions. The first one is under a challenge, as I mentioned before. The other one is, the group of birds with no challenging conditions, and then using all the data, and then using plasma only in the starter diet. And then you see body weight gain, it improves overall about 2%. And it's very interesting that it improves in both groups, in chickens under challenge and in chickens under no challenging conditions. So intake, very little effect. These ones here are not statistically significant. So very little effect. And then feed conversion under a challenging situation, you actually improve it quite substantially by 5.2%. And in birds under no challenge is 2.5% improvement. So all the data indicates that altogether will be at 3.1%. And if you feed it in the starter diet, you will have a 3% improvement at the end of the life cycle of the chicken. And then livability, there's not a lot of data. So I think the more reliable estimate here is this one, using all the data, because there's not a lot of data to call it under challenge and no challenge, and to call that a robust test. So here is more robust. So the other thing is that if you feed plasma in the starter diet versus in all the life of the chicken and so on and so forth, you capture most of the value of plasma, you see. So with feeding only in the starter diet, you will improve 3% feed conversion to body weight gain, 2% on average. So, and livability 0.9 is in the right direction, although not statistically significant because there's not a lot of data on this. So anyways, this is what you expect from feeding plasma in the first few days of life of the chicken and feeding 3 to 4 grams. So why 3 to 4 grams and how can we formulate plasma? We formulated at 1 to 3% in the first diet. And then you have to calculate how much the chicken eats in your first diet and then formulate accordingly to reach 3 to 4 grams of total cumulative intake per chicken. So we have done this type of work. This is one of the trials. This was done in the in Thailand at the BARC, the Ajinomoto Research Station there. And the authors here, they fed plasma for 5 days or 10 days at different concentrations. And so if you calculate the spray-dried plasma intake, you see this spread in data. So more or less the tip of the curve occurs at 3 to 4 grams of plasma. And this is overall productivity efficiency factor. So if you see feed conversion, you will find something similar, and also body weight gain. So usually 3 grams of plasma is typically paid back by 1 point of feed conversion in most countries. So and just to detail a little bit more how you formulate plasma, so you have to feed between 1 to 3% of plasma. The problem is that there is a lot of starter or pre-starter diets or dietary programs. So this is feed intake, cumulative feed intake, and this is just from the COP guide. I just put it in this graph to illustrate how intake changes over time. So if you have, for example, a diet of 5 days, let's say, you would expect an intake of 101 gram approximately of feed intake. So in such a case, you feed 3% of spray-dried plasma, and that'll give you 3 grams. So 3% of 100 is about 3 grams. So, but if your diet goes from 0 to 7 days of age, you reduce the percentage to 2%. So the intake, the cumulative intake is going to be about 167. So 2% of that will be 3.3 grams. If you have a diet for 10 days, for example, from 0 to 10 days, that's your starter program, then you feed just 1%, and that'll give you 3 grams. 10 days, the chicken eats about 300 grams, so 1% of that is 3 grams. We do not recommend feeding less than 1%. Because there's little data on that percentage, and the few data that is available today suggests that the response is a little variable if you feed less than 1%. So anyway, so what is the percentage of plasma that you should be using? It really depends on your started program, whether it is for a few days or 7 days, 10 days, etc. So, and the minimum is 1%. So I'm going to show a couple of experiments that were conducted by Sergio Vieira in Brazil. Sergio Vieira was the head of nutrition of BRF for some time. He's a consultant now. He's also a professor. Well, he has this barn. It's a commercial barn, and then he has these boxes within this barn. So you can see the number 90. So he has 90 boxes here. So each one of these boxes had 25 chickens. So the idea was obviously to simulate the commercial environment here, and then you have the 25,000 chickens here loose in the rest of the barn. So in this case, we tested 7 treatments. There was a control, and then we fed plasma for 4 days, for 7 days, or for 10 days, and then we calculated what was the expected intake, and then what would be the percentage in the diet to reach 1.5 grams, 3 grams of intake per bird, 3 grams in 4 days, 7 grams in 3 grams in 7 days, or 6 grams or 3 grams in 7 or 10 days. So it's a combination of length of exposure to plasma and intake or total intake of plasma. So the density was commercial and so on and so forth. This is, we really got an unexpected event. The mortality was extremely high. I mean, there was a multifactorial, but between bad chicken quality and also we had a problem with E. coli, and then it got complicated with Proteus and also with Streptococcus. And the bacteria, those 3 were actually resistant to antibiotics. So, and in this case, we use N-Romycin, and it didn't stop the mortality. The mortality began at 12 days of age. So then you see the mortality was quite high because nothing stopped this infection. It was 83% for the control group, and this is cumulative mortality up to 42 days of age. So we lost 83% of the control chickens. And then we had, I think we had 9 replicates here. No, more than that, 11 to 12 replicates. So, and then in 4 days, 1.5 gram, it really made a difference to these chickens. So we reduced a lot the mortality. And then feeding 3 grams, there was a further reduction in mortality. You see that 3 grams in 7 days or 4 days is similar. And then 10 days, 3 grams is also similar. So anywhere between 39 and 35% of mortality. And then more in this case was of benefit because the challenge was quite a lot. So, but still 6 grams in 7 days or 6 grams in 10 days were actually quite similar. And we reduced the mortality down to about 15%. So the reduction in mortality was quite amazing, from 83 to 15%. That's a lot. So there was also benefits in feed conversion, body weight gain, and so on. So for lack of time, I'm just not showing them. So, and then we repeated the trial because it was supposed to be the trial in commercial conditions with commercial birds, and everything should be perfect and so on. And this is trial number 2. And then you see that there was clearly a plasma effect in body weight gain. If you see feed conversion, you will see something similar, improvements in feed conversion. And this was actually independent of dose. And another thing to point out, that the performance of the birds was actually quite good. You see the cub target here. And then there was the control, the body weight gain of the control was actually higher than the cub target. So all in all, we improved significantly the body weight gain of these birds by 126 grams on top of this control diet. So as I mentioned, body weight gain improved, feed conversion improved. Also, there was a reduction in mortality and so on. So, and then another kind of trials that we're doing is actually promoting large field trials. And this is because commercially, it's obviously very difficult to do commercial trials with many replicates and so on. But as you're feeding plasma only in the first diet, it is possible to deliver logistically just the first diet in a farm, and then, or in many farms, and then compare it to sister farms or you know, control group. So in this case, we had 105 farms. This is 1.1 million chickens. So we were able to place 54 farms under plasma and 51 under the control. And actually these farms, they were all housed the same time within the same couple of weeks. And every day we had plasma and control farms being allocated. And also they all were in the same region. So there's not an effect of climate, there's not an effect of time of housing. So, which is the ideal situation. So, and these farms, these diets actually contain bacitracin and also contain high levels of copper sulfate as a growth promoter. And in this case, 1% was fed for 10 days. And this is the PhD thesis of Bruna Bellotti. She's a student of Elizabeth Santin, from the University of Paraná. So we involved the University of Paraná, a PhD student, and so on, to run the trial and to collect samples and everything else. So, and this was presented in Montreal, and it was sent for publication at Poultry Science a month ago, or a little bit more. So anyways, these are the results, and what the researchers decided to do was to separate the chickens by type of housing. So they separated it in negative pressure barns and positive pressure barns. And that's because the positive pressure barns in that operation is an older technology. What they were, those are older barns. So the idea was that probably the birds were under more stress with these positive pressure barns versus the negative pressure barns. And then we use HAT slaughter as the measurement of growth, because they follow the performance of the chickens, and then they sell them when they reach a target body weight. So you can see the control, and then you can see the plasma group, and you see the p-value here. So in both negative pressure barns and positive pressure barns, there was a reduction of 1 day in slaughter age or age at slaughter. So numerically, 52 days of age, the body weight gain, the body weight of these birds was superior to this group, and also the plasma group in the positive pressure barns, numerically they had higher body weights. So they reach higher body weights, or let's say the same body weights 1 day before. And then feed conversion actually improved 5% and 4.5%. It was similarly improved. And then you see the p-values here. So that was a statistic. And then the mortality was very low, 3.3. For a 53-day-old chicken is very low to me. And still you see an improvement in a reduction, significant reduction in mortality. So we have seen this in many trials where you have healthy flocks with relatively low mortality, and still you see a slight reduction in mortality. So statistically significant. So, and then, you know, they evaluated the birds of these animals by necropsy, and also they took histological samples of intestines. And they evaluated it using the IC method, which is a method developed by that university. So basically you see these are the organs, the systems, respiratory, you know, gastrointestinal, and these different organs. And these are the alterations that they observe in the ritual of the necropsy ritual. So, and they score, you know, foot pad lesions, and they give score, pigmentation, and so on. And the score goes from 0 to 3. And then they sum up the scores per system. And that is a measurement of the health of the flock. So they also can actually sum or add all the scores or average all the scores, and that'll give you an idea of the total health status of the chickens. So they call it, you know, they separate the gastrointestinal organs versus intestinal organs, and also the lesions due to coccidiosis. So, and these are the results. You see that with spray-dried plasma, the findings, the pathological alterations found in the chickens is actually significantly lower than the control group. So, and this is the overall of all those observations. But particularly, there was a reduction in lesions related to coccidiosis, and this is, again, clinically healthy flocks, and also a reduction in problems related to bone health, which is very interesting. This is, we have seen bone health benefits by using plasma in other models. So very interesting results. So anyways, the complete report is very big. They measure a lot of things. They also measure histological alterations, and then you will see lower pathological alterations under the microscope too. So those are field trials. Another area that we're very interested on is the plasma effect in chickens of different quality. And this is a work done in Mexico recently. And what these workers did was actually they selected small chickens at placement. In this case, they weighed 36.6 grams with plasma and without plasma, and then 40 grams and then 44 grams of body weight. So you had lower initial body weight, then medium, and then let's call it high, 44 grams. So you feed plasma, and what is interesting, this was 2% for 7 days, which is an application I like. And then this is the performance at the end of the life cycle of these chickens. And then you see that the smaller chickens had better response or responded more vigorously than good quality chickens, let's call. And the response was intermediate for the intermediate weight chickens. So chicken quality is an interesting area of research for these applications on spray-dried plasma. And then these workers also measured with this new technique, they call it the real-time morphometry in the duodenum, and check that, you know, this was done at 15 days of age. And then you see the control group, and you see plasma. These pictures are actually taken in fresco, pretty much. So they euthanize the birds, and they process them right away, and they take the pictures there. at the barn. So then you see that with plasma, there's more villi than the control group. And then you see the height of the villi height is actually greater with plasma. So you see more villi and greater or larger villi. So if you calculate the area of absorption, it actually increased 8.8% in plasma. So, and this is the numbers associated with these images. So you can see the p-value and the benefit of plasma here in gut development. So this is a measurement of gut development and health in these animals. So there's a lot of information. There's a lot of new information also on plasma. These are the main effects that we have actually observed. So we have seen improved performance on a wide variety of conditions, and then you have some references here. Then there's increased tolerance to disease. We have seen actually in many diseases. I just put the three that I thought was that were more important. And then increased tolerance to stress. We have a lot of information on heat stress, stocking density, bad housing, chicken quality. As we said, you know, it seems that small weight chickens respond very well. I just showed the results of one trial, but there's another one done in Brazil with the same results, with similar results. And health benefits, you know, gut health, bone health, overall health. We have seen actually improvements in respiratory diseases, increasing the resistance of chickens to respiratory diseases. So vaccination efficiency, this is efficacy. We actually see increases in, for example, in antibody response to vaccination programs of Newcastle and infectious bronchitis. This is something that has caught our attention too. And with coccidia and coccidia vaccination programs. And we have seen reduced mortality, as we mentioned in the meta-analysis. There is a reduction in mortality of about 1.3% overall with the data that is available. And these are some examples. We see it about, you know, when we run a trial, we see it about 50% of the times, statistically significant improvements in or reduction in mortality. So as you know, mortality is hard to measure and is quite variable, but the effect is there. So, and of course, for early nutrition, development of immune system, development of gut and high digestibility. And one characteristic that is very interesting is that you can actually use it with antibiotics and additives. So from the experience in pigs, we have seen that, you know, plasma works well in piglet diets with antibiotics. We carried on and published information. This is from Texas A&M on the use of plasma with antibiotics. We also showed this very large field trial in Brazil, for example, with antibiotics, and still you see that there's an additive effect. So this means you can use plasma in the context of your nutritional, of your feed additive programs. So overall, what you will see is an improvement in feed efficiency, weight gain, and reduced mortality. And you will see an increased tolerance to stress and disease. That is basically in a nutshell, what's going to happen with the use of plasma at the recommended levels that we have. So thank you very much for your time. Appreciate your time, your patience here.
All right, thank you, Dr. Ricardo. And now come to the question session. I would request Mr. Rick, Mr. Ramesh to open and join the question and answer session now. I will be a bit in hurry because we are already passing like 1.5 hours. Some of the audience may have to engage with other things. So the question go to Ricardo. The first one is the dry plasma, the APC product free of any pathogen?
It's actually a safe product. As I mentioned before, it is a safe product. There is a lot of innovation and research on the processing of plasma. testing different methods to make sure that the product is safe. And as I mentioned in the second slide, is used widely and is free of salmonella. It's obviously exposed to the air and so on. So and it is not in a vacuum package. So there'll be some microorganisms, but just from the environment. But yes, it is a safe product, and there's a lot of information to back that up.
All right, so the next question go to Mr. Rick. I would like to get a live question for you. Talking about the early nutrition, the audience asks, how early is early that you mean? And what is the normal practice the farmers have done, try to calm down on arrival of the sheep at the farm, and then given water, then given the feed. They think that to calm down, because to avoid the stress factor during the transport. They want to know that not only how early is early, but the practice to calm down the sheep, it's really applicable, or can we just introduce the feed to the day old sheep right away?
Ricardo may be able to help me here, but we do not hold feed back for any reason. When the birds are placed in the house, the feed is on the floor on paper, because the sooner they can start eating or drinking, the better. So we do not hold feed back for any reason. So the earlier, the better. And in fact, if you could feed them in the hatcher trays, that would be the best. Obviously, there are problems with doing that. Ricardo, perhaps you can add your 2 cents worth here.
Yeah, I think the earlier the better. And if you hold off, of course, there's a linear detriment on keeping the birds off the feed. What we have seen in some trials of chicken quality is that 24 hours. If you hold feed and water for 24 hours, you got a bird that is not able to respond to nutritional strategies. So they start actually losing their capacity to respond to nutritional strategies. So the earlier the better, of course.
All right. So the next question is a bit like the combination of various questions that I gather here. It is about, when you say it's very important in early nutrition, how exactly the spray dry plasma will help the flock. Will help in the uniformity, it will help an average daily gain or FCR. Can you both, Rick and Ricardo, to summarize the point? I think this will answer the 5-10 questions regarding to the importance of the early nutrition when we implement the spray dry.
Perhaps I can start just from a nutritional point of view.
Yeah.
Remember that a couple of things I said. The first is you want a highly digestible ingredient for these baby birds. And there's nothing more digestible than blood plasma. Okay. It hasn't got any ash in it, and it hasn't got fiber. Now, ash and fiber are both indigestible, so you don't want them in the diet. The second major advantage of using some plasma is that it allows you to moderate your soybean inclusion in the diet. Because you don't want too much soybean in a chick diet. There's a third issue, is that it probably allows you, because it's got such a high biological value, it probably enables you to achieve lower crude protein and hence lower indigestible protein levels in the diet. So now I'm not even talking about the functional aspects that I expect Ricardo to talk about. These are just straight making feed and feeding them to birds benefits of a product like this. Obviously, there's a cost associated with this, and if it was just on this grounds, it would be difficult to justify. But there are functional reasons, and perhaps Ricardo can take over from me and answer that part of the question.
Yeah, thanks, Rick. Yes, on the functional aspects, of course, there's two keys to understand plasma, and one is the development of an efficient immune system, so the effect that it has on the immune system, and the other one is the acceleration of the gut development in the young birds. And these two aspects should be actually key objectives in your nutritional program, because they will impact everything. So if we try to summarize the benefits in terms of body weight gain, feed conversion, and so on, because that's easy to communicate. But whenever you impact immunity, and whenever you impact also gut development, that has a lot of ramifications, of course, in different aspects. And one of them is obviously the tolerance to diseases or stress that we have been showing, and of course, increased productivity overall.
All right. So I think I'm gonna cover another two questions. The first question go to Mr. Rick is, what is the nutrient profile that suit the early nutrition?
Yeah, it's a multi-dimensional question, because the answer is in multiple dimensions. The first is you need to decide how much balanced protein you're going to put in the diet. The bottom line is the more the better, but somebody's got to pay for that. And often in the open market, you are obliged to do what your opposition do. So you can decide you want 15 grams of available lysine and the opposition is using 13 and you've got no choice. So commercial bad.
Yeah,
the second thing is that we're becoming increasingly aware of is that we want to reduce the oversupply of undigested proteinaceous material. And there's been some really great work published by the group working out of Sydney together with Evonik at the moment, showing that if you can reduce the crude protein without reducing the amino acid content, you have a significant improvement in performance. So what I want to say is, what profile should we use? Don't get hung up on using too much crude protein. Really consider using synthetic amino acids. Having said that, when we start using synthetic amino acids, we need to be aware that the amino acid profile probably needs to be adjusted. And what you need to do is you need to adjust your threonine levels upwards, you need to adjust your sulfur amino acid levels upwards, and you certainly need to be very conscious of valine, isoleucine, and arginine. You cannot ignore them, as we probably did in the past. So that's the second part of that. And then in terms of energy, I know people like to see 13 megajoules, what's that, 3,000 calories roughly. I don't see any benefit in having too much energy in this baby chick diet. Perhaps Ricardo can pass a comment on that. I actually like to see a little bit of wheat bran in my starter diets. It gives me better crumbles, and maybe that's more important. Ricardo, you want to help me there?
Yes, yes, I agree with you. If high energy diets, if you have a diet from 0 to 7 days of age, you don't really need high energy diets. And I see a lot of people using high fat content.
Me too.
These diets, which is actually detrimental. But if your diet goes from 0 to 10 days of age, the fat content is going to kick in from 7 to 10 days. And you may see an effect there. But it's not because the bird is going to benefit the first 7 days of age. So So I think the length of period that you're feeding is a consideration, but I'm with Rick. I wouldn't, I see, you know, we think about 3,000 kilocalories, 2,900 kilocalories, and we worry too much about the kilocalories in early diets. And I don't think that's, it could be detrimental actually if you're feeding too much fat.
Yeah, I see diets with 3% fat in them, starter diets, and it doesn't make sense to me.
Not at all, not at all. Palm oil.
All right, so I think we come to the last question. I would put to the audience here. If you are interested in the nutrition value and also the formulation you want to do for your layer, the day-old chick for layer or broiler breeder, you can contact Mr. Ramesh. He will connect you with the technical person of APC. That would be better because it's different diet across the region. So the last question I would ask is, actually, it's a mix of the two things on the digestibility of our APC, the spray dry plasma. What is the digestibility of the spray dry plasma compared to the same product that has the nutritive value? And back to Mr. Rick on the bad negative effect of the high ash in the feed. What is that negative effect? It is
well, let me start by just saying, and I've repeated it already, that ash is just indigestible, and if you give a young bird indigestible material, what it does is it just takes space up in the gut for material that is worthless. And as I say, we always thought about fish meal as being this wonderful ingredient, but if you go and look at how much ash is in 60% protein fish meal, you'd be horrified. It's silica. It doesn't do any harm. It just fills the gut up with sand. And what's the point of that? You're desperately trying to get nutrients in. And that's where a product that is highly digestible, I mentioned prime gluten. Prime gluten is highly digestible because all the fiber and all the indigestible and the oil has all been removed. It's just a processed protein, maize protein, and it's highly digestible. And Ricardo, maybe you can just add to that for the blood plasma.
Yeah, what plasma contains is actually sodium. Is an element that is present there because of the anticoagulant that you use, and we recommend you spec sodium, and you use that value for balancing sodium in your diet. But that's the main component on minerals, let's say. The contribution of the other ones is just very small, negligible. So anyways, and that's on the mineral content, and on the amino acid content, the amino acid digestibility compared to other products. We actually we did some research with Carl Parsons very recently to put our own specs using Carl Parsons. So as you know, Carl Parsons from the University of Illinois is an authority on that. And what we found, we actually did digestibility of plasma in chickens of 10 days of age and in chickens of 21 days of age. What we found is that the amino acid digestibility of plasma at 10 days of age is around 95%. It depends on each amino acid, but it's around 95%. And then at 21 days of age is about 96%. So that means it's very, very high in very young animals. So it also means that the early chicken is actually well prepared to digest these kind of proteins. When we look at the products out there, we were making comparisons using the tables, the FEDNA tables, for example, also the tables in Brazil, the Brazilian tables. They actually list amino acid digestibility values of plasma in chickens. And I realized that they use products with lower protein to test that. Their specs is probably 72% protein in those tables, and the values are lower. My suggestion is ask to your manufacturer what is the specs, what are the specs of their product, and question where did he get those values from. That'll be my suggestion, because there's big differences in manufacturing practices.
All right. Thank you very much for Mr. Rick, Dr. Ricardo, and Ramesh for today's session on the early nutrition by using the APC products. So this is very innovative products that, of course, can utilize the product that come from the animal production. So today I would like to thank you to our speaker and apologize to all of you that we stay 20 minutes late than the early schedule. And of course, for the audience here, thank you very much for joining with us. For those questions not yet answered, Mr. Ramesh will coordinate and get answer back to all the audience. And see us again with the APC webinar with the aquaculture strategy feed with APC. Thank you very much and see you again. Swadika.
Many thanks.
Yes.
Thank you. Thank you, Mrs. Rose.